All right. My name is Will Hewitt, and this is my midterm. I'm gonna primarily just read them off of the Word doc that I have up here. Um, so, first question. Uh, Morrill, in one of his theories, suggests that space is always, albeit subjectively, optimized. How has the physical geography of Michigan made this optimization of space easier and/or more difficult? Also, is regional optimization also impacted by time or time periods? Excuse me. And I said that the diverse, um, as far as how the optimization of space is made easier, the diverse and varying physical geography of Michigan allows for vast amounts of utility by humans. The freshwater lakes and fertile soil allow for abundant use of water and lots of produce. Industries such as fishing and hunting thrive as well, with the wildlife that is drawn to the particular geography that Michigan provides. There's also iron and copper within northern rock deposits in the Upper Peninsula that have been used by the UP occupants to utilize and or sell. Um, One difficulty that I noted from uh, a PowerPoint is that there's the rugged western part of the Upper Peninsula that allows for very little to no inhabitation by humans. That's one example of a difficulty um, of space optimization in Michigan. And also to address the last question, regional optimization is greatly impacted by time. Optimizing space is completely different 100 years ago than it is today, or it was completely different than it is today. All right, question number two: climate, climate, soils, and vegetation transition evolve in Michigan at about the same latitude. Elaborate on this phenomenon. Um, sorry. Um, I said started off with climate. Um, so the state's seasons are a direct result. I'm gonna explain each climate, soils, and vegetation separately, and then kind of combine them all at the end. The state's seasons are a direct result of its middle latitude location. The axis and rotation of the Earth, combined with its revolution around the sun, helps produce different climates all around the world. Michigan receives long summer days due to the high angle of the sun above the horizon during the summer months. Michigan also receives lots of solar energy due to longer exposure to the sun's rays than in other seasons, which um, allows for a lot of heat and higher temperatures in the summer. During the winter months, there are shorter days due to the lower angle above the horizon of the sun, and the smaller amount of radiation, which cut down on the heat, which cuts down, which cut down on the heat in Michigan. For the soils, sandy soils are more common in the western and northern parts of the state, but western UP and northern UP, or just the whole Upper Peninsula, and then northern Lower Peninsula. Um, and clays and loams are more prominent in the southern and Lower Peninsula. Now, vegetation. Uh, Forest composition seems to follow certain trends as one moves from south to north. The further north you travel in Michigan, the larger amounts of coniferous tree species there are. These species appear to be sensitive to warm and dry summers and aren't as competitive with each other than when you compare them to other species that thrive in basic or neutral soils. And this makes the coniferous species limited to the northern Lower Peninsula and the Upper Peninsula, where the summers are cooler and the soil is sandy and acidic. But the line that kind of separates and divides all these aspects uh, separates the Lower Peninsula from the north and the south, and from where there are more coniferous species, and then there's less coniferous species, and from where there is um, sandy soils, and where there are clays and loams, where there's cooler summers and warmer summers, is the line called the floristic tension zone. And the cause of this divide is it's still debated that what makes the line so um, what defines the line or where the line even is. Um, but the evidence that I discussed before tells that it's some sort of combination of climatic control and or soil differentiation. And then the third question. Above a certain volume, snow becomes firn, and then ice. Ice, that's my dog. And then ice. Ice exhibits a certain plasticity. What is this plasticity? What does it translate into when applied to glaciers? And which glacial landscapes are a byproduct of this plasticity or lack of plasticity below a certain ice thickness? So the plasticity is the movement of ice, of glaciers. I think that's what they're referring to. So when glaciers exceed a depth of 200 feet, they begin to flow. They can no longer support themselves and will start to move. A lot like the Jello example you gave in your one of your PowerPoints, one of your videos. So the glacial ice will keep moving once it's over 200 feet until the depth goes back to below 200 feet. But when this happens, the ice in the front that is below 200 feet will stop. However, the rest of the glacier that's still over 200 feet will keep moving. And the glacier moves along the surface of the earth and brings debris with it. And so the larger, over 200 feet deep part of the glacier will slide along the top of the less than 200 feet deep section and will bring the debris out to the front. So the ice carrying the debris on the bottom, once it reaches the nose of the glacier, the glacier will then move up into the top of the glacier, which always carries it's still carrying the debris with it when it's doing this. And that explains why the tops of glaciers appear dirty, because they're always moving up and on the top. So the dirt comes out, gets on the front of the glacier, and it continues to stop. And also keep moving at the same time. And then this debris that the ice is carrying, it will set up as it stops and goes, will set up these deposits of debris. And once the ice melts around it, the debris becomes glacial canes or hills, such as Boyne Mountain in northern Michigan. That's an example of one of those such hills or glacial canes. All right, last question. How and why do mineral resources spatially differentiate between the Western Peninsula and the Lower Peninsula in Michigan? So I said economically important minerals are formed differently in different parts of the state of Michigan. Iron ore and copper are found in deposits in the Western Upper Peninsula and are formed by igneous and always formed by igneous and metamorphic processes. Petroleum, natural gas, salt, limestone, and gypsum are found in the Lower Peninsula and are formed by sedimentary processes. The Eastern Upper Peninsula and the Lower Peninsula are comprised of sedimentary rock layers, also known as the Michigan Basin. These rock formations were left on the bottom of ancient seas that existed long ago, where the Michigan Basin exists today. The rock formations rest directly upon the old Precambrian bedrock surface. The igneous and metamorphic rock comprises the Precambrian bedrock layers, and they act as the base for the sedimentary layers piled on top, and are therefore piled on top, and are therefore more exposed on the coastlines, and also they're exposed on the outskirts of the basin, such as the coastlines, and then up north in the western UP, where all the copper and iron ore are. And that iron ore and copper are they exist deep beneath the sediment. They still exist beneath the deep sediment layers of the Michigan Basin, but they're more accessible on those outskirt areas like the coastlines and especially western Upper Peninsula, where no ancient seas were located and no sediment is piled on top of. But this explains why the minerals differentiate spatially in the state of Michigan and why they're more accessible. Some are more accessible in western upper peninsula, and then other things like petroleum, natural gas, salt, limestone, and gypsum are more accessible in the lower peninsula. And that is all I have for you. Hopefully that is good enough. Thank you.